In our last page, what we're going to do is we're going to be provided with some information about foci or vertices and covertices and create an equation for an ellipse. Taking a look at our first exercise, if these are your vertices, halfway in between your vertices is your center. Also notice the vertices are negative 10, 0 and positive 10, 0. That means this is a wider ellipse. Your center would be 0, 0. So if your center equals 0, 0, then we know the tops of our equation would be x squared plus y squared over some fraction, which equals 1. If your major axis is in the horizontal direction, that means we're going to add, we're going to put this value or the value of a squared underneath the x. So let's see, these are 20 apart. That means the major axis is of length 20, and half of that would be 10. 10 is the value of a, so a squared is 100. That was really quick, but I feel like we got that. Covertices. Now these are 18 apart, 9 from the center. 9 would be the value of b. 9 squared would be 81. And it's just that simple. We've created our first equation. X squared over 100 plus y squared over 81 equals 1. Our second exercise, look at the values for your vertices. The vertices are 0, 6 and 0, negative 6. This is a tall ellipse. Halfway in between the two vertices would be the point 0, 0. 0, 0 means that we know the tops of our equation, our x squared and our y squared, are divided by two different numbers and it equals 1. 12 units apart, 6 away from the center. 6 squared is 36. Because it's taller, I'm not going to put it underneath the x. I'm going to put it underneath the y. The covertices are 5 units away because the length is 10. So half of that is 5. 5 squared is 25. And that's pretty simple. If you're given vertices and covertices, our next exercise does not give us that. It gives us vertices and foci. So let's take a look at how this is a little bit different. Halfway in between your vertices would be your center. The length of the major is 12. The length of the major is 24. Half of that would be 12. And also notice 12 left and 12 right. That means we have a wider ellipse. So our center is going to be 0, 0, or halfway between that. That midpoint connecting the two vertices would be our center. Again, we know that x squared plus y squared equals 1 with some sort of denominators. I feel like we discussed that 24, half of that's 12. 12 squared is 144. It's going to be wider, so we'll put it underneath the x expression. Now let's be clever. What are we given here? We're given the distance from foci to foci. Well, technically we're given the two coordinates, but we know the difference is 2 times the value of c. So from the center, how far away is this compared to the center? It is 2 root 11. That's our value of c. When you square c, you get 4 times 11, or 44. So c squared is 44. Let me write down c squared equals a squared minus b squared. We know that c squared is 44, again, because the value of c is the difference of the center to the focus, to one of the focus, squared. That's 44. Equals 144 minus b squared. I mean, we can manipulate this and get b squared equals 100. Let's put the b squared on the left, subtract the 44 on the right, and guess what I'm not going to do? I'm not going to square root this because I want b squared in our formula. So this would be the formula for number 3. Let's work on question 4. Question 4, halfway in between the two vertices would be our center. Our center is again 0, 0. Length is 28 of the major axis, so half that would be 14. 14 squared is 196. So let's take a look at what we're going to do. X squared over something, y squared over something equals 1. To the left and to the right, which means we have another wider ellipse. So I'm going to put that 196, which was 14 squared, underneath the x. Doing the same thing what we did, we have c squared equals a squared minus b squared. The value of a squared is determined because they're from the vertices, so you know that's the major axis. We don't know the length of the minor axis. How far away are these to the center? This is 3 root 19 away from the center of 0, 0. So what I'm going to do is I'm going to square the 3 and square 19. The square root of 19 to get 19. 19 times 9. 19 times 9 is 171. It gives me c squared. What I'll do is I'll move the b squared to the left and the 171 to the right. So b squared equals Let's see, 5 and a 2, so b squared equals 25. And this is your equation down below. So we got that. All right, let's take a look at the information, how it changes our setup for our last two of the day. Let's take a look at the two foci and covertices. We don't know where the vertices are. Let's take a look at the covertices and let's determine if this is tall or wide. The covertices are on the minor axis. The x-coordinate is changing. So that means the covertices are left and right, which means the vertices are up and down. This will be a tall ellipse. Where is the center? The center is not only halfway between the vertices, it's also halfway in between the two covertices or the two foci. So if we had figured out where the midpoint is of a line segment containing these 2 points, we would add the two x's, divide by 2 to get -7. We would add the two y's, divide by 2, but there's no sense in doing that because it didn't change at all. So -7,5 is the location of the center of our ellipse. By now you should have found out how to plug in the coordinate for your center. Alright, now let's take a look at what we know. The minor axis is horizontal. That's going to tell us the b squared underneath the x squared term. They are 12 units apart. Half of that is 6, and 6 squared is b squared, is 36. Okay. Let's take a look at our formula. C squared equals a squared minus b squared. We know b squared is 36. Let's take a look at how these compare to your center, your foci. The length from your center to the focus is length c. So from the center to the focus, it's root 13 above 5 and root 13 below 5. That makes c the square root of 13, and c squared equals 13. Let's add 36 to both sides. A squared equals 49. Let's confirm this does make a taller ellipse because it's underneath the y. And there's your equation for number 5. Last one, number 6. The foci are always contained on the major axis. So left and right, your foci, that means we have a wider ellipse. Halfway in between the location of your two foci would be our center, so we can just do like midpoint again. We can add these and divide by 2. The center has an x-coordinate of 3. Add those, divide by 2. Our center is 3, 9. That gets us started with the numerators of our ellipse formula. Now let's figure out these denominators. Our covertices are up and down. So here's 3, 6, and here's 3, 12, and here's 3, 6. So let's see, how far are they apart? They're 6 units apart, so half of that would be 3. 3 would be the vertical, so that would be 3 squared would make 9. 9 goes underneath this spot. C squared equals a squared minus b squared. Since this is our minor axis, let's put b squared equals 9 underneath here. We're looking for the value of a because we're given our foci. How far away from the center is each focus? 4 units away. That makes this c squared. 4 squared is 16. 4 squared is 16. Let's add 9 to both sides. Looks like the value of a squared is 25. Sorry, I wrote that off the page. And that finishes our lesson. Our homework tonight is going to be a mini check-in with Google form. So please complete that. Remember to email me if you have any questions. Have a great day.